Hello there. Thanks for checking out my video today on solving polynomial inequalities. To start here, we have a two-problem opener that you should try to solve these two problems on your own without any assistance. Pause the video at this point, give them your best shot, and come back and check your answers when done. Okay, hopefully you came up with these answers to the warm-up problems. All right, so today what we're going to look at here, let's skip past this first slide for a second and go to the second slide. This is the type of problem we're going to look at today. It is a polynomial inequality. Now this one is in factored form. This one is not in factored form, but they're all the same. Okay, we are looking for when this inequality is true. So here's how we're going to do this. Okay. The inequality is true when f of x is negative. This inequality is true when f of x is positive. All right, how are we going to do that? We are going to first start by thinking of the inequality as an equation and solve it. And these are called your critical numbers. We're going to create a sign chart using these zeros and critical values. We're going to test a number in each interval to determine whether it's positive or negative, or there's a shortcut using multiplicity that we'll talk about as we go through these as well. And your solution set are the values that make the inequality true, either negative or positive. Finally, we'll write our answers in interval notation. We're going to write them in interval and inequality notation just for practice today, but usually we want our answers in interval notation. All right, let's take a look at our first answer. When the problem is in factored form like this, it's great because we can find our critical numbers very quickly. All right, our critical numbers are going to be x equals negative 2, x equals 1, and x equals 3. Then we're going to place those numbers numerically in order on a number line. Okay. Then we're going to decide, are our circles going to be open or closed? And it's very simple to know. Does it say equal to or not? Since it does say equal to, our circles will be closed because that's when this will equal 0. If it was open, this would be just greater than, and vice versa. Okay. Now we're going to pick test points in each of these 4 intervals. Okay, so our first interval, maybe we pick x equals negative 3. And we're not looking for an actual number, just think about what we get back. So if it was negative 3, it would be negative times something squared, so that's positive, times negative 4 cubed, which is negative, times negative. So it's negative, positive, negative, negative. That's going to give us a negative answer. All right, in the second interval, maybe we pick 0. That's an easy one to pick. So it's going to be negative, positive, negative, negative. So it's also negative. So I picked x equals 0 for that test point. For the third one, maybe x equals 2, negative, positive, positive, negative. So that's 2 negatives. So that's a positive there. And for our last one, maybe x equals 4. So negative, positive, positive, positive. 1 negative is going to be negative. Okay. So finally, our answer is where this is greater than or equal to 0. So our answer is simply right there. Okay. So our answer is going to be all the numbers that are in the set of negative 2, but also 1 to 3. Okay. And if we want to write that in inequality notation, it would look like that. So interval notation, inequality notation. But don't forget this negative 2 out there is also an answer. Okay. Now I told you there's a shortcut for doing this, and there absolutely is a great shortcut to this. All right, where you only need 1 test point, which is so much better than 4 test points, right? So if I'm going to pick 1 test point, I could pick any test point I wanted. Let's say I picked x equals 0 as our test point, and we got back that this is negative, which we still would get back it's negative. All right, then you look at the multiplicity of each 0. So negative 2 is squared, right? It comes from here, which is squared. If this number is even, we don't change signs as we cross over that 0. So if this is negative, this is also negative. 1 comes from here. We look at the power here. If it's an odd number, we do change signs as we cross over that number. 3 comes from here, which is also an odd number. So again, we change signs. All right, that's called using multiplicity as a shortcut. I always say if you don't understand that shortcut, it's not a big deal. You can simply pick test points for each one if you want. When I do these problems, I will always be talking about the shortcut moving forward. But if you don't understand what I'm saying, you can just simply pick test points in each interval. Example 2. Again, it's in factored form, which is great. So our zeros are 0, 5, and -2. All right, if we draw a number line including those 3 zeros. All right, now I'm going to use my shortcut here and pick test points. But before I do that, are the circles open or closed? Since it's not equal to, our circles are open. Now I'm going to pick just one test point. I'm going to pick x equals 1, because that's probably the easiest test point I could think of. We put that back in, and we get 1 times some positive number times some positive number. All positive, so this is going to be positive. Now, as I cross over 5, 5 comes from here, which is an even multiplicity, so I don't change the sign. As I cross over 0, 0 comes from here, which is an odd multiplicity, so I do change the sign. As I cross over here, -2 comes from here, which is an odd multiplicity, so I do change the sign. So my answer is simply where it is less than 0, which is right here. So our answer is -2 to 0, or in inequality notation, -2 is less than x is less than 0. Third one, this is the first one not in factored form, so we're going to put it in factored form by factoring. And we get our 2 critical points, which are -4 and +2. Set up our number line. Are the circles open or closed? They are open because it's just less than. If I pick 0 as a test point and put that back into my inequality, I would get negative. And both of these are odd multiplicities. So as I cross over each way, I change the sign to positive. The answers are where it is negative. So it's just -4 to 2. Or -4 is less than x is less than 2. Number 4. It looks like it's in factored form, but in fact it is not. So what we're going to do is we're going to distribute the x in and bring the 20 over to this side. And then I'm going to put it in factored form. So my critical points are -5 and 4. And they're going to get closed circles here. If I pick a test point, maybe x is equal to 0 as my test point, and put it back into here, I get a negative answer. Both these are coming from one multiplicity, so odd, so both times we will cross over, we will change. Our answer is where it's greater than or equal to 0. So our answers are -∞, -5, close bracket, union, close bracket, 4 to infinity. All right, or we can say x is less than or equal to -5, or x is greater than or equal to 4 in inequality notation. Okay, one more like this. Let's start by subtracting the 4x squared over and putting this in factored form by taking out a GCF of x squared. We're still not done yet. And now it's in factored form. So my zeros are x equals 0, x equals 2, and x equals -2. -2, 0, 2. Open or closed circles are going to be open because it's just less than. All right, let's pick a test point. How about x equals 1? We put that back in here. We get 1 minus 4, which is negative. Okay. Over 2, that has odd multiplicity, so we will change signs. Over 0, that has even multiplicity, so we don't change signs. Over -2, that has odd multiplicity, so we change signs. My answer is where it is negative, so my answers are here and here. So my answers are -2 to 0 and 0 to 2. Number 6, this is the same problem. It's just asked a little differently. It's asked in a sentence instead of just a mathematical inequality. We want to know when this is greater than or equal to 0. So we're going to set this greater than or equal to 0. And if we factor, we get our zeros to be 5 and -2, our critical points. Greater than or equal to 0, which means close circles. If I pick a test point, how about 0? Put it back in here. We would get a negative answer. Both these come from odd multiplicities, so we'll change signs over both of them. And we want our answer to be greater than or equal to 0. So my final answer is -infinity to -2 inclusive, and then 5 inclusive to infinity. Or x is less than or equal to -2, or x is greater than or equal to 5. Number 7, consider the domain of f of x equals root x. So find the domain of f of 3x minus 5. So f of 3x minus 5 would equal root 3x minus 5. Now, we've done these problems earlier in the year, but remember, we can't take the root of a negative number. So we want 3x minus 5 to be greater than or equal to 0. Solving that, we get x is greater than or equal to 5/3. So that would be bracket 5/3 to infinity. All right, now how about finding the domain of this one? So we are doing root x squared minus 2x minus 8. All right, so we want that, I'm going to put it in factored form here, to be greater than or equal to 0. So our critical points are 4 and -2. Close circles, because that'll make it equal 0, and we can't take the root of 0, right? Pick a test point in there, we would get -8 if we use x equals 0. Both these are odd multiplicity, so we change signs over both of them. Right, and that would give us positive, negative, positive. Remember, we want it to be greater than 0, so our answer is going to be -infinity to -2, bracket, union, bracket, 4 to infinity. Okay, or we wanted to write that as x is less than or equal to -2, or x is greater than or equal to 4. Okay, on this last slide, we are going to go backwards. I'm going to give you the answer, and I want you to give me the original inequality. So the first one says -6 to 1. All right, so that means we got our critical points from these two equations, which means our inequality must be x plus 6 times x minus 1 something 0. Our job is to figure out what this something is here. What sign are we going to use here? Okay? So if we create a test chart here, a sign chart, and if we pick a test point, how about x equals 0, and put that back into this, we would get 6 times -1, which is negative. This is positive, and this is positive. Because our answer is here, that means that this is the solution. Because the brackets are, because they're parentheses, that means they're open circles. So that means our sign must be less than 0. So our final answer is x squared plus 5x minus 6 is less than 0. Now, are there other answers to this? Absolutely there are, but that is the easiest, most basic one to come up with. All right, last one. So we got x minus 2 and x minus 5, something 0. Okay, if we create a number line, well, first of all, let's go ahead and simplify this. That'd be minus 7x plus 10, something 0. Now, if we create a number line with those two answers on it, and pick a test point, I always pick 0. It's just the easiest test point to pick, I think. And put that into here, we would get positive 10, so positive. And since it changes signs, it's negative positive here. Because there's brackets, these are going to be closed circles. And our answers are less than 2 and greater than 5. So our sign is going to be greater than or equal to 0. Because these are both positive. So greater than or equal to 0. Okay, that will do it for this lesson on polynomial inequalities. Thanks as always for checking out the video today, and we'll see you next time for rational inequalities.